Okay, so good day everyone. So today we will be discussing C++ operators. So what is an operator? So an operators are used to perform operations on variables and values. So for example, we use the addition operator to add together two values like this one. Int x equals 100 plus 50. So let's try it on our C++ program. So we put x equals 100 plus 50. So if we output x, the answer should be 150. So that's how you add, or that's how you use operator. Just a simple example. So although the plus operator is often used to add together two values like the example above, it can also be used to add together a variable and a value. So we can add a variable and a value. For example, if we change this to a, and int a equals let's say 50, so the output should be oh, I forgot a semicolon, sorry. So the output should be 100. So you can also use operators like this: a variable and a value. And you can also do it with both variables, or a variable and another variable. So if we change this to b and we put another variable, b equals, let's say, 25, so the output should be 75. So that's it. That's how you declare, or that's how you use operators in C++. And in C++, we have divided the operators into the following groups. So you have arithmetic operators, you have assignment, you have comparison, you have logical, and lastly you have the bitwise operators. So that's how you add numbers or integers. So you just need to, you can either put a value already or do it by a variable. So variables, you can declare several variables of the same type in one declaration. You can use a comma separated list like this one. So we can, but for good programming practices, it should be one statement per line or one variable. But in some cases, you can also do it this way: comma b equals 25. You can also do that one. It could be a comma separated list, or a different, or one statement per line. So you can do that one. If you have many variables, you can do int x, y, z, g, h, j, like this one. But for good programming practice, you need to separate those. So you can, for example, you can put description. This is for the a variable, and for this one, this is for the b variable. So the description for this variable will be this one, and the description for the b variable b is this one. So that's why you need to declare one statement per line or one initialization of variable per line. And variable name, so must be a valid identifier, a series of characters like letters, digits, and underscores. Cannot begin with a digit, always keep that in mind. No variable should start with a number, and it is case sensitive, so uppercase letters are different from lowercase letters. So for example, if we put another int capital A equals 25, or let's say 30, and we change this to capital A, so your output should be 80. So that means small letter A is different from capital letter A, so it is case sensitive. So this A is different from this small a, so always keep that in mind. So adding integers, assignment operator, we will discuss this. That is the equal sign. So assigns the value on the right to the variable on the left. So that means the left side and the right side. It is a binary operator, meaning two operands. Two variables are involved. So the example is sum equals variable 1 plus variable 2, like this one. Int x is equals to a plus capital A, this one. So it will add 50 and your 30. And it adds the values of variable 1 and 2, stores the result in the variable sum. So we can change this one x to sum. And change this one to sum. So it will do the same. So concatenating stream or insertion operations. So you can use multiple stream insertion operators in a single statement, correct? What if you will connect a label and a value or a variable. So stream insertion operation knows how to output each each type of data, and it is also called chaining or cascading. So for example, this one, so let's concatenate this. We will put another insertion and put a label. So the sum is, and let's try it. So you will have this one, meaning this one, you concatenate the string the sum is to the variable sum, this one. This is called concatenating. You have two insertion points, this one and this one. That is called chaining or cascading. So the new outputs a new line and flushes the output buffer. So like that, the one that I gave you, this one. You can also put another chain here, your escape sequence \n, so the cursor will go down. The cursor will go down, and here it will start a new line at the bottom. So that's how you use chaining or cascading. This is the outline. This is the format of the program I gave you, this one. So first, you need to declare your variables or your integers. You can also input numbers if you want, like this one and this one. Then store it to the sum integer, and you can use this std and then a double colon if you do not declare, or you did not declare the using namespace std here. So if you did not put that using namespace std above, you will use this one on each of your cout and cin. So let's try. Int that's int a. Let's remove this one. So sum is equals to b. Let's see in a. And then cin b. And then we put labels. Cout enter a. And then here we put label, we remove the value, enter b. So that is for your inputs, this one. So let's try. So we enter a with any value as long as it is an integer. So we try 34 and then hit enter. Then we input the value of b, an integer, the same integer 23, and then we hit enter and it should give you the sum of the two numbers. 34 plus 23 is equals to 57. So that's how you use input and output. This one is for the input of a and for the input of b. Then it will do the calculation on this part and it will output the sum on this part. So that's how you use cout and cin. So assigning data, so initializing data in declaration statement. So results undefined if you do not. So int my value is equals to 0. So that's the initial value. So assigning data during execution. So you have the left value or the left side and you have the right values or the right side. So the left value must be the variables and the right values can be any expression. So example, this one, this is the left value, which is distance, and you have the right value, which is an expression, rate times time. So in our example, this is the left value and this is the right value. So data assignment rules. So compatibility of data assignment. So type mismatches. So I already told you about type mismatches before. So general rule, you cannot place value of one type into variable of another type. So as what I have said, if you put an integer type, you cannot do it with a double or a float type. So if you put a decimal number on an integer, so it will just give you a whole number. So for example, this one, int myvar, and you put a decimal 2.99, it will give you 2 instead, since myvar is an integer. So only integer part fits, so that's all that goes. So it is called implicit or automatic type conversion. It will not give you error, but it will convert the decimal point to an integer. So that's you do not forget that one. And for literals, you also have literals. like this one, 2, 5.75z, a character, hello world. Consider constants since they cannot be changed in program or inside the program, like this one. You cannot change this while naka sa imuhang program. If you are already on the program, you cannot change this this string, the sum is. If you already run this one, you cannot change this to the subtraction of, you cannot change. So that's why it is called literal or constant. You cannot change it while you are on the program. Literal data, it's the same. That's a literal 2 for integer, meaning you cannot change it on your program. The character and the string, you cannot change values during the execution. So if you already run your program, you cannot change those values. So that's why it's called literals or constants. So called constants because you literally typed them in your program. Constants is the same. So naming your constants, literal constants are okay but provide little meaning. For example, seeing 24. So tells nothing about what it represents. So what do you mean by 24? Seeing 24. What 24? Is it a number? Is it a group? Is it just a sign 24? So you need to put description or variable on it or representation. So you use name constants instead. So a meaningful name to represent your data. For example, this one, int number of students equals 24. So you already know that that number 24 is the number of students. So it is called a declared constant or name constant. So now use its name wherever needed in the program, just like the variables I told you a while ago. You can use it whenever you want, wherever it is needed. So added benefit is it changes the value results in one fix. Correct. So we go to arithmetic operators. So you have these types of operators. You have multiplication, this one, star. You have division, forward slash. Integer division truncates or discards the remainder. So this one, 7 divided by 5 evaluates to 1. Since you that operator cannot give you the remainder. So 5 or 7 divided by 5 is 1. That is in mathematical expression, it is supposed to be 1 remainder 2. But in program, in division, arithmetic division operator, it will not give you the remainder. So it will just give you the whole number. So 7 divided by 5 will become 1. And you also have the modulus. So the modulus operator returns the remainder. So unlike the division operator, modulus operator will only give you the remainder of the two values. So for example, this one, 7 modulus 5 is equals to 2. Since 7 modulus 2 is 1 remainder 2. So it will just give you the remainder 2 as an answer. So that's the difference between the division and the modulus operator. And also common programming error, attempting to use the modulus operator, the one I gave you with non-integer operand, is a compilation error. So it will give you an error if you use any data type aside from an integer. So it will give you an error, keep that in mind. So arithmetic, a straight line form, it is required for arithmetic expressions in C++, and all constants, variables, and operators appear, it should appear in a straight line so that you can understand the program better. grouping sub-expressions, like using parentheses are used in C++ expressions to group the sub-expressions. It is the same in your mathematical or algebraic expressions. So example is this one. A times B plus C. So multiple A times the quantity of B plus C. So that's an example. This is the table for your arithmetic operators. So you have addition, this one. You have subtraction, subtract, almost they are the same. For multiplication, this one, B times M. Here it is B times M also, but with a star. Division, still the same. And for this one, modulus, it is for your algebraic expression, it is R mod S. For our program C++, it is R mod S, but with this 1% sign. So arithmetic rules of operator precedence. So operators in parentheses are evaluated first. For nested parentheses, operators in innermost pair are evaluated first, the same as on your mathematical expressions. And the same MDAS, it is multiplication, division, and modulus are applied next. Operators are applied from left to right. And last is addition and subtraction. Operators are applied, still the same. It will be from left to right. So the precedence, this is the precedence or pasunod o asa imuhang unahon og evaluate. So the first is the value inside the parentheses. So it should be evaluated first. And if the parentheses are nested, the expression in the innermost pair is evaluated first. So meaning if you have many parentheses, you have parentheses and inside that parenthesis also another parenthesis. So it should be the innermost that will be evaluated first. So if there are several pairs of parentheses on the same level, they are evaluated from left to right. So for example, just an example, int x equals a plus b plus c times d, and then here we put another minus e parenthesis. So for this one, it is evaluated from left to right. So for this part, you will be evaluating first the innermost parentheses. So this one is the same level as this parenthesis. So, and this parenthesis has another parenthesis inside, which is this one. So this is the innermost parenthesis on the expression. So this will be evaluated first. So d minus e. So you have the you need to subtract this one. So once you have the answer, so let's say it will be f. So this one has the same level as this one, but you need to evaluate first multiplication versus addition. So the next evaluation will be this one. So you need to multiply c and f. Let's say we'll give you g. So it will not, you will not have a parenthesis anymore. So the next part is this one, since it is on the parentheses, and you need to evaluate parentheses first. So you need to evaluate this one. So a plus b, let's say it will give you h, and then you evaluate this part until you get the value of x. So that's how the precedence or operator precedence works. So you need to do the parenthesis first, and then if there is no parenthesis anymore, you need to look for the multiplication evaluated second. If there are several, they are evaluated the same from left to right. Then if no multiplication, look for the division and modulus, and if this is gone, then the next part is the last one, which is the addition and the subtraction. So that's the precedence of your arithmetic operators. So arithmetic operators are used to perform common mathematical operations. Like this one, we have the addition adds together two values. Like this one, the same as example. This is the arithmetic operation of addition. Int sum, and it will give you the sum. Then for subtraction, it's still the same. You just need to change the sign to negative or a minus sign, and let's just put this x, and the product, not the product, let's say the value of x. So it will be general. The value of x is this one, x. So let's take an example. Let's try it. So we enter a, so 50, and b, this is for subtraction. Let's say 34. So the value of x now will be 16. So 50 minus 34 is equals to 16. So that is for the subtraction of your numbers. This one, subtraction of x and y. For our example, it's subtraction of a and b. Then we move to multiplication. Still the same. Let's just change the sign to star. That's for our program in multiplication, not the dot. That will not work. It is star. So let's run it. So let's put a 5 and b for 9. So it should give you 45. This one, a times b. And for the division, still the same. It's just a division. Change this to /. Yes, that's /. So let's try division arithmetic. Let's try 24 divided by 6. Should give you 4. So that's for your division. How about for your modulus? So let's try modulus. Modulus, that one. So let's try it. So modulus, let's try any number. 25 modulus 5. So this should have no remainder, right? So it should give you 0. So that's 0. We try another number with a remainder. 24 the modulus 5. So it should give you a remainder 4. Yes. So it will just give you the remainder of the numbers. For this, modulus operator.